Bismillahirrahmanirrahim. I'm Siti Zaniza binti Tohar from Faculty of Chemical Engineering and Natural Resources, University Malaysia Pahang. Today I would like to share with all of you about my research study, which is chemical weathering of S-type granite and mineralogy characteristic of ion-adsorption type REE deposit in nilai semenyih saprolite horizon. I will divide my presentation into 5 subtopics. The first one, I will explain about location of the research. The second one, I will explain about the methodology that we use. The third one, I will explain about the weathering profile. The next one, I will explain about the mineralogy and geochemistry of the profile. And the last part is I will explain about the conclusion of the study. The research study are located at Nilai and Semenyih area. Both are located at the main range belt granite, which is the S-type granite rocks. These locations had a total rainfall around 1 to 2,000 mm per year. The methodology for this research study, we prepare the sample, we divide it into two. The hard rock sample, which is the granite, we send to the jaw crusher and thermometer and to become the powdered samples. And for the soil sample and the saprolite sample, the soft samples, we just send to the thermomills to become the powdered samples. And then after that, for the mineralogy analysis, we do the XRD and the transmitted light microscopy. And for the geochemistry analysis, to analyze the elements, we do the XRF, the SCM, and the ICP-MS analysis. The result from the fieldworks observations, the weathering profile of nilai semenyih granite contain 4 different type of layers. The bottom is the parent granite, where the CIA value is around 40 to 42%. And there's the second layer is subrock, and the third layer is saprolite, which is this area is the potential area for the REE ion adsorption type because the CIA value is more than 80% and it contains a huge amount of clay minerals. And then we do the mineralogy analysis for the S-type granite in nilai semenyih, and we found that the three main RE bearing minerals are monazites, cerianites, and also alanites minerals. The monazites is about 15 to 100 millimeters diameter and it's pale yellow color. And we also do the SCM analysis to look at the image and the pattern of the RE fluorocarbonate, and we found alongside the kaolinite clay minerals, the RE fluorocarbonate attached with kaolinite and also the RE fluorocarbonate filling fractures in chlorides. And the Conrad normalized RE pattern of saprolite layers, it show the large negative europium anomalies and significant positive cerium anomalies. This indicates REE ion is enriched in REE bearing mineral resistant to weathering and not fully transport down to the saprolite layers. And then the S-type granite weathering profile are likely to contain a relatively high proportion of weathering resistant REE bearing minerals, and therefore their weathering products will show a limited level of enrichment in REE. So the conclusion for this study is the granite in nilai semenyih area have been subject to tropical climate with extensive rainy season to allow sufficient weathering to concentrate REE from a fresh granite body into a relatively saprolite zone of adequate thickness. The second conclusion is the weathering profile in nilai semenyi granite are divided into 4 horizons, which is soil, saprolite, saprock and fresh granites. The third conclusion is saprolites are red and yellowish brown in color, range in thickness from 5 to 10 meters, are the pointation layer for REE ion-adsorption type deposits. And the last conclusion is the low occurrence of REE fluorocarbonates in nilai semenyi granites indicates low grade of REE ion-adsorption type concentration in saprolite layers, because mostly the REE contain from high resistant weathering minerals such as monazite and alanites. That's all from me. Thank you and Assalamualaikum.